Chapter 8 Probability Exercise 8.4 12th question. A coin is tossed thrice. Find the probability of getting exactly 3 heads or at least 1 tail or 2 consecutive heads. So it's given that a coin is tossed for 3 times. Now we have to find a probability for 3 events. So getting exactly 2 heads, let us take this as event A, and at least 1 tail, so let us take this one as event B, and 2 consecutive heads, let us take this one as event C. And what about this R? Yes, this R stands for union. So now we have to find the value of A union B union C. Is it clear, students? Yes. Let A be the event of getting exactly 2 heads. A is from the sample space. So we are going to take the sample point that is exactly 2 heads. So this is sample point that has exactly 2 heads. Then H, T, H, T, H, H. So we can write here head, head, tail, head, tail, head, and tail, head, head. So these are the 3 sample points which has exactly 2 heads. So what will be our n of A then? Its number of sample points in A is 3. So now we have to find a probability value for this one. P of A is equal to n of A by n of S. Substitute the values here, we will get 3 by 8. Let's move to the next event. So what's the next event? Yes, let B be the event of getting at least 1 tail. Look at this sample space. Now we are going to select the sample points that has at least 1 tail. So that is at least 1 tail. So it may contain 1 tail or 2 tails or 3 tails. So B is head, head, tail, head, tail, head, head, tail, 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 head, head, tail, head, tail, then tail, tail, head, and the last one is tail, tail, tail. So these are the sample points that has at least 1 tail. We have tried n of B. So number of sample points here is 1, 2, 3, 4, 5, 6, 7. So n of B is 7. We have to find a probability value for this one. P of B is equal to n of B by n of S. Substitute the values here, we will get 7 by 8. Let C be the event of getting 2 consecutive heads. Look at this sample space. Here, head, 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 tail, and tail, head, head are the 3 sample points which has 2 consecutive heads. So let us write C now. C is head, 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 tail, then tail, head, head. So n of c is equal to 3 sample points. Now we have to find P of c. What's the formula to find P of c? P of c is equal to n of c by n of s. Substitute the values here, we will get 3 by 8. The next point we have to find A intersection B. So that is the sample points common between A and B. The sample points common between this A and B are head, head, tail, head, tail, head and tail, head, head. So A intersection B is head, head, tail, head, tail, head and tail, head, head. N of A intersection B is equal to 3. Now we have to find P of A intersection B, which is equal to N of A intersection B divided by N of S, which is equal to 3 by 8. Next we have to find the sample points that are common between B and C. The sample points common between B and C are height, HT, then the next one is T, H. B intersection C is head, head, tail and tail, head, head. N of B intersection C is equal to 2 sample points. Now we have to find its probability value. P of B intersection C is equal to N of B intersection C divided by N of S. So you will get the answer as 2 by 8. Now we have to find the sample points that are common between A and C. Sample points common between A and C are HHT, then THH. A intersection C is HHT, then THH. So these are the 2 sample points that are common between A and C. Now let us write N of A intersection C is equal to 2 sample points. Then its probability value is equal to N of A intersection C divided by N of S. Substitute the values, we will get 2 by 8. So what's the last step? So now we have to find the sample points that are common between A, B and C. What are the sample points that are common between A and B and C? Yes, the sample points head, head, tail and tail, head, head. So these are the 2 sample points that are common between A, B and C. So from this, N of A intersection B intersection C is equal to 2 sample points. Now let us find its probability value. P of A intersection B intersection C is equal to N of A intersection B intersection C divided by N of S, which is equal to 2 by 8. The next step, we are going to substitute the values in the formula. So what's the formula for P of A union B union C? Yes, that is P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. Let us substitute the values here. That is P of A is 3 by 8 plus P of B is 7 by 8 and P of C is 3 by 8 minus A intersection B is 3 by 8, B intersection C is 2 by 8 and A intersection C is again 2 by 8 plus the last one is A intersection B intersection C is 2 by 8. Here we can cancel this plus 3 by 8 and minus 3 by 8. Here minus 2 by 8 and plus 2 by 8. Here the denominator is common. Let us write the numerators 3 plus 7. Here minus 2 which is equal to, simplify the numerator, 8 by 8 which is equal to 1. P of A union B union C is equal to 1. Thus, the probability of getting exactly 2 heads or at least one tail or 2 consecutive heads is equal to 1. Is it clear, students? Question. In a class of 35, students are numbered from 1 to 35. The ratio of boys to girls is 4:3. The roll numbers of students begin with boys and end with girls. Find the probability that a student selected is either a boy with prime roll number or a girl with composite roll number or an even roll number. In a class of 35 students, the ratio of boys and girls are given as 4:3. The 3 events are a boy with prime roll number, a girl with composite roll number and even roll number. So let us take these events as A, B and C, and this R stands for union. So here also we have to find A union, B union, C. Let us solve this one. In our sample space, the numbers are from 1, 2, 3 and so on up to 35. And what will be our N of S? N of S is equal to 35. So it's given in the question that the ratio of boys is to girls is 4:3. Now we are going to find number of boys. That is 4 divided by sum of these two into total number of students. It is equal to 4 divided by 4 plus 3 is 7 and total number of students is 35. Now you can cancel this one by 7 tables. 1 7 is 7, 5 7s are 35. So number of boys is equal to 20. Then what will be number of girls? Yes. So from the 35 students, we subtract the number of boys, then we will get number of girls. Let A be the event of getting a boy with prime roll number. So A is 2, 3, 5, 7, 11, 13, 17 and 19. So N of A is equal to 8. Now we have to find its probability value. P of A is equal to N of A by N of S. Substitute the values here, we will get 8 divided by 35. Let B be the event of getting a girl with composite roll number. Now list out the composite numbers from 21 to 35. Yes, they are 21, 22, 24, 25, 26, 27, 28, then 30, 32, 33, 34 and 35. So what is the n of b then? N of b is equal to 12. P of b is equal to n of b by n of s, which is 12 divided by 35. Let's see with the event of getting a student with even roll number. So even numbers from 1 to 35 is 2, 4, 6, 8, 10, 12, 14, 16, 18, 20, 22, 24, 26, 28, 30, 32 and 34. So from this we have to write it as n of c. So number of sample points in C is 17. Now we have to find its probability value. P of C is equal to n of C by n of S, that is 17 by 35. The next step, that is the sample points common between A and B. Is there any sample points common between A and B? No. So here the sample points in A is less than 20. Here it starts by 21. So there is no common sample points between A and B. A intersection B is equal to null. So from this you have to write it as n of A intersection B. Number of sample points is 0. P of A intersection B is equal to n of A intersection B divided by n of S, that is 0 divided by 35, which is equal to 0. The next step, we have to find the sample points that common between B and C. The sample points that common between B and C are 22, 24, 26, 28, 30, 32, 34. N of B intersection C is equal to 7 sample points. Now we have to find its probability value. P of B intersection C is equal to n of B intersection C divided by n of S, which is 7 divided by 35. Next we have to find the sample points that common between A and C. Is there any common sample points between A and C? Yes, there is only one sample point. 2 is common between A and C. So n of A intersection C is equal to 1. P of A intersection C is equal to n of A intersection C divided by n of S, which is 1 divided by 35. In the last step, we have to find the sample points that common between A, B and C. Is there any sample points common between A and B? No. So from this, n of A intersection B is equal to, there is no common sample point, so this is 0. So let us find its probability value. P of A intersection B intersection C is equal to 0 divided by 35, which is equal to 0. So what's the formula to find P of A union B union C? Which is equal to P of A plus P of B plus P of C minus P of A intersection B minus P of B intersection C minus P of A intersection C plus P of A intersection B intersection C. Now we have to substitute the values here. P of A is 8 by 35 plus P of B is 12 by 35 P of C is 17 by 35. A intersection B value is 0. B intersection value is 7 by 35 and A intersection value is 1 by 35, and the last one A intersection B intersection C is 0. So this is plus 0. So here the denominators are same. Take the common denominators as 35. I can simplify the numerator. So here 8 plus 12 is 20, 20 plus 17 is 37, 37 minus 7 is 30, 30 minus 1 is 29. So the answer is 29 by 35. Probability of A union B union C is equal to 29 by 35. Thus, probability that a student selected is either a boy with prime roll number or a girl with composite roll number or an even roll number is equal to 29 by 35. Is it clear, students? Yes. Thank you.